Hello, I'm Michael Whitehouse, and through this video I'm going to be showing you how to set up Windows Server 2012 file and storage services, and we're also going to look at deduplicating data, two of the most interesting features in Windows Server 2012. Firstly, you might be noticing I'm running on a Mac. I'm not using Hyper-V at the moment. I'm using Oracle's VirtualBox Manager to run these virtual machines. We have a domain controller running Windows Server 2012 over here. The domain controller for this demonstration is not actually going to do anything, it's just going to provide me domain services to my standalone machine running over here. This standalone machine, if you have a look down at the storage spaces, is actually running 4 hard drives or 4 virtual drives. We have one drive that's going to be running with the operating system on it, and we've actually got 3 completely blank drives. These are the drives that we're going to use to weld together for our storage spaces. So if I just get rid of that for the moment and bring up the Windows Server 2012 virtual machine, let's make that full screen. Okay, so this is Windows Server 2012, and hopefully you've logged in and had a look at this before. We have our basic desktop, we have our start menu, and so on and so forth. We'll go over those at a later date. But what we want to look at is the new Windows 2012 Server Manager. One of the default things you will find in Server Manager that's actually popped on here when you drop on a full GUI installation is the file and storage services. So if we drop over on the file and storage services on the left hand side, we can see from here a selection of servers on our network that are currently running file and storage services, just SVR1 at the moment, the server that we are currently on. If I click into volumes, I should be able to see a couple of the volumes that are currently running on this system. The system reserved volume and the current C drive. Now C volume is what is holding our operating system. If on the other hand I go into disks, we should be able to see those 4 disks. That first disk is actually containing the volume C, which is containing our operating system, and we've got our other 3 disks that we saw within VirtualBox, the virtual hard drives that are just 20 gigabytes in size. Now this is where we want to actually do our storage. So if we go into storage pools, go away Action Center. If we actually go into our storage pools, what this allows us to do is to take resources from a variety of different sources, from physical disks that are plugged into the system through to iSCSI disks that might be plugged in over the network or from from SANs in our infrastructure. Once we've actually got these into our system, if I go into the traditional MMC console, file, and remove snapping and drop into disk management, you may recognize this from older versions of Windows. I don't want to initialize those disks at the moment, but we can see down here there's our 4 disks. I haven't actually done anything to these disks at the moment. They're not initialized, they don't have a master boot record, they don't have a GUID partition table, they don't have any volumes on them whatsoever. They're just like completely blank drives plugged into the system, as if you'd taken the shrink wrap off yourself and plugged them in. But this is what we're going to actually use to create our storage pools. So let's create a simple storage pool. If we come back into File and Storage Services, Volumes and Storage Pools down here, the first option you'll see is we actually have a Primordial Pool. Now, when creating storage pools, we don't actually put data directly onto the disks. We weld the disks together in a storage pool to create a large amount of space. And then secondly, we create virtual hard disks, or VHD or VHDX format hard disks, off the pools that we create from our physical disks, allowing us very, very flexible storage. So our Primordial Pool is going to contain disks that are not used, that have not got any data on them at all, just like you've seen in Disk Manager. So the first stage at the moment is to pick our disks. What are we going to use? So I want to actually use 1, 2, and 3. I want to use all 3 physical disks down here. So if I click on Tasks and click on New Storage Pool, we get this lovely little wizard. Within this wizard, I can choose to name my storage pool. I'm going to call this, I don't know, Temp Pool 1. That'll be fine. Click next on that, and then we get the option for selecting which disks from the Primordial Pool that we actually want to include in this storage pool. I want to actually include all 3 disks for the moment. If I had multiple disks, I could select just a 2, 3 or 4 of maybe 10 or 20 individual disks that we have in our environment. And we have two different options for the allocation of those physical disks. Do we want them to be automatically allocated, i.e. do we want Windows to be able to store things on those disks, or do we want them to be provided as a hot spare? If it's provided as a hot spare, Windows won't use these disks for any storage spaces, but it will be able to pull them in later on if we have individual failures. So, just reviewing, confirming everything that I've selected throughout the wizard, and then hit create. Now what that's actually done is it's created us a storage pool. Now if I move this new storage wizard out of the way, we should be able to see temp pool 1 listed up the top there. The capacity of 57.8 gig and 57 gigs worth of free space. Remember, we welded together 3 20 gig drives, so that's about right, about 60 gigabytes worth of space available to us. But we can't do anything with it. We can't just store information right on there and start creating partitions like you would with a RAID array. What we actually have to do now is create virtual disks off that temporary pool, or off that temp pool 1 that I've named. Happily, in the wizard itself, it brings up this lovely little option that says create a virtual disk when this wizard closes. So if I just check that, hit close, it's going to throw me up a brand new wizard. And from this new wizard, I can create virtual disk or virtual hard drives off that temp pool 1. So let's go through this wizard. Select the storage pool that I want. I only have one storage pool available to me at the moment, the one I created, and I can start to create virtual disks. So let's call this temp disk 1. Oh, actually, let's call it temp VHD1. Much better. Now, what you'll notice is we have a nice option called the storage layout option. We can choose to have this as simple, mirror, or parity. Now, you might be thinking to yourself, well, that looks like RAID. It's RAID 0, RAID 1, and RAID 5. Yes, it achieves the same goal. But since this is done entirely in software and split across those 3 disks, even if we chose to actually have a simple disk, the data is striped across physical disks, maximizing capacity, increasing throughput, but decreasing reliability. So as a simple disk, we would expect there to be no redundancy in there. If the disk failed, or if one of my physical disks failed, we might lose data. But that is still spread across all 3 physical disks. The same with the mirror. With the mirror, it would be duplicated across multiple physical disks, and it would always make sure that the data for that VHD is stored on at least 2 or 3 physical disks. Parity is one of the most interesting things though, because this achieves the additional option of, instead of mirroring, when we would lose essentially half our storage space, we have 10 gigabytes worth of data, we need to duplicate it again 10 gigabytes over the top. So it takes 20 gigabytes to store 10 gigabytes worth of data. The parity, on the other hand, runs with the same ratios as RAID 5. So we only actually lose 1/3 of the space to the parity information to be able to recover our information if we have a disk failure. So if I go to parity, we have the option to do thin or fixed provisioning. This relates to the equivalent of dynamic and fixed size virtual hard disks. If I choose thin provisioning at the moment, this isn't actually going to create a VHD that's going to take up all the space that I specify. It's only going to create a very small VHD, but allow it to expand to the space that I need. So let's give this a virtual hard disk size of 5 gigabytes. And if we look down here, we can set 5 meg, 5 gig, or 5 terabytes. What's actually really nice about storage spaces is you can overcommit. I could choose here to create a 5 terabyte drive if I really wanted to. The VHD would look like it's 5 terabytes to the system, but all that's available to it on the back end is 60 gigabytes worth of storage space. Actually less than 60 gigabytes, considering we have to use 1/3 of the information for parity information. But we could choose to add disks to our storage space afterwards. There's no reason why we can't throw in more hard drives later on and add them to increase the size of our storage pool, of our temp pool 1 that we've created. For the moment, I'm just going to create a 5 GB disk. Click next on that and click create. So that's creating a virtual hard disk that's then going to be stored on temp pool 1. Now, since it's a VHD that's been created, it does not have any volumes on it at all. So we need to create some volumes. Normally, we go through Disk Manager or use the Disk Part tool to format that drive, but since this is Windows Server 2012, and again, it's a Microsoft operating system, so very wizard driven, we have this lovely little option again that says create a volume when the wizard closes. So if we leave that selected, it throws up the lovely new volume wizard for us, which is the same as we get through the MMC console. And we can see now we've got temp VHD1 here that we've created. Click next on that. Just create a volume for the entire disk, and we'll give it a volume of M for the heck of it. That'll do. Call the volume name Hello World. Leave it as NTFS. We do have the new REFS system down here if we want it though. And click create. And close that down. So, now what we should have, as soon as this refreshes, inside temp pool 1, we have the physical disks that are associated with temp pool 1, and we have temp pool 1's VHD, what's going on with it, and where it's actually attached to. So if I go into the file structure here, click on computer, there's Hello World M. So if I right click on that, go to new, and create a text document in there called Hello World. I can spell. And there we go. That data, that Hello World text file that I've just created, is split across all these drives. It's paritied. So if any of these physical drives fail, not a problem. Our data's all safe. So the other thing you might want to do within this is deduplication. And deduplication has been around for quite a while with SANs. And what deduplication essentially allows us to do is when you look at data on a large hard drive with a large amount of data on a block level, you might find that some of those blocks match. And if some of those blocks match, it's duplicate data. Data deduplication will go through and delete those duplications and will put pointers into a single location rather than having that data exist in multiple places at once. Now we can add deduplication into Server 2012 and do it on a software level. This is a great thing to do on your file servers, and you might find yourself saving a heck of a lot of space. Deduplication is not dropped in by default though, we actually have to go off and install this. So if I go into Manage and Add Roles and Features, click Next, Role-Based Feature Installation, that's fine. We want to do it on SVR1, that's fine, that's what I'm on at the moment. And if we go into File and Storage Services, File and SCSI Services, we should find Data Deduplication. So let's add that feature in and install that feature. It shouldn't require a reboot for Server 2012, and it shouldn't take too long to install at all. Data deduplication does add in a few PowerShell tools as well, so you can control this like pretty much everything through Server 2012 by PowerShell if you really want to. So once I've had this added in and I refresh again, you should be able to come up to Volumes, go to M, right click on this, and I'll have the option to configure data deduplication. So if I click on data deduplication and enable deduplication for this volume, the default setup is to deduplicate files older than 5 days. Now, if we want to have every single file deduplicated rather than just files over 5 days, set this to 0. We can choose to exclude specific extensions, and we can choose to exclude specific folders. Sometimes data deduplication is not the best thing in the world to run on drives that may, or volumes that may contain live databases. We click the Set Deduplication Schedule. We can choose to actually do this on our file servers at specific times. You might want to just do deduplication in the evenings or the weekend when nobody's in the office. But for the purposes of this demonstration, we can have background optimization. This is going to continuously deduplicate all files that are thrown into the system. You should really only have to do schedules if you do have a very, very intensively used file server. Your average file server, you can just leave that to enable background optimization. If we apply that and OK that, we have just enabled deduplication for the M drive, considering there really isn't any data in there apart from my hello world text document. We're finding that the data deduplication rate is 0% and the deduplication savings is 0%. But if you choose to add in more information to this, you can see some massive savings. You can see savings in excess of 60 or 70% if you've got a lot of virtual hard drives in here with virtual machines. If I look into PowerShell, we have the option to get dedupe job. Get dedupe job at the moment is not showing me anything because background optimization is not happening. If you do have background optimization continuously going on, you should be able to see information there from get dedupe job. But just to show you what this PowerShell looks like, get dash command where dash name dash like star dedupe star. Oops. Let's get my PowerShell a bit here. And that completes our tutorial for how to set up deduplication and how to set up storage spaces in Windows Server 2012, or storage pools and storage spaces in Windows Server 2012. And as you can see, if we just run the command get dash command pipe where module name equals deduplication, we can see all the commands that we've actually got for deduplication within PowerShell. So you can do full PowerShell administration for deduplication if you wish to see your current deduplication rates and set your current deduplication schedule. And that completes this tutorial for deduplication and Windows storage spaces on Windows Server 2012. I hope this has been informative for you, and I'll hope you'll tune back in for more. Thank you very much.